In today's class, we'll discuss the topic super dense coding. This super dense coding is a protocol uh, which is complementary to the operation the teleportation protocol. What do we do here? We try to transmit two classical bits instead of an qubit. Now, these bits are to be transmitted from the receiver sender to the receiver side with the help of one E bit and an qubit. So Alice will take both the persons into consideration. Let Alice act as the sender who sends two classical bit and Bob is the receiver. Now Alice tries to convert the two classical bit into an qubit with the help of the X gate and the Z gate. And number two, Alice and Bob shares an entanglement bit which is termed as E bit. Now, 2 points to note down. Without the shared E bit, Alice will not be able to transmit the two classical bits to Bob. Number two, we have an theorem termed as Hollywood's theorem, which implies two classical bits can be transmitted reliably with the help of an single qubit, not in terms of the classical bits. So with this information, we'll just try to understand the circuit which is provided for the super coding protocol. The circuit is presented over here. Two classical bits in terms of A and B are transmitted from the Alice perspective. B undergoes the Z gate operation, where bit A undergoes the X gate operation. What does these two gates do? B performs a phase flip, which means when there is one, value 1, it gets converted to an phase flip of -1. What about A? A goes ahead with an not bit flip, which means 1 is converted to 0 and 0 is converted to 1. Then this information is being combined with the Bell gate 5 plus, which is an shared E bit between Alice and Bob and is transmitted to the Bob side. Onto the Bob side, the qubit was received undergoes an control NOT operation, followed by an Hadamard operation, and then moves on to the classical bit measurement, which reveals B and A. So this is all about the how fine. So Alice transforms the 5 plus entanglement bit into classical bits. So to remember, X gate flips both the states, whereas Z gate performs and phase flip. With this information, the bits A and B can have two possibilities. A can be either 0 or 1, which can be transmitted. Similarly, B can be also 0 or 1, which is transmitted. If the bit is 0, 0, now 5 plus is the entanglement bit which is provided over here. It is get 0, 0 plus get 1, 1 by root 2. Since A and B are both 0, neither the X gate operation nor the Z gate operation is applied, and the output which is transmitted from Alice to Bob is 5 plus as it is, which is get 0, 0 and get 1, 1 the whole by root 2. But what if the value of A is 0 and value of B is 1? Since value of A is 0, we will not apply an X gate operation. But since value of B is 1, we'll perform an Z gate operation, which means we perform an phase flip where bit B is 1. So bit B is 1 over here in get 1, 1, and you have a phase flip operation resulting in get 0, 0 minus get 1, 1. Phase flip introduces a negative sign. So it is get 0, 0 minus get 1, 1 by root 2, which is similar to the state get 5 minus. Moving on to the third case, if the bit A is 1 and bit B is 0, X gate is performed and not the Z gate operation. And therefore, the first bit, first get 0 value and this get 1 is being flipped. 0 is flipped to 1 and this 1 is flipped to 0, resulting in get 1 0 plus get 0 1 by root 2, which is get 5 plus operation. The last case, where both A and B values are 1. What really happens? Both operations X and Z is being applied. On the application of X, you have 0 which is converted to 1 and 1 which is converted to 0. Now Z operation has to be applied where you have 1 on the second part, because when you have 2 0 0, the first 0 indicates something related to A, the second 0 relates something related to the second input B. And therefore, first 0 and first 1 relates to A, where you do an bit flip operation. Second 0 and 1 relates to B, where we do an Z operation, and therefore it is 1 0 get 1 0 minus get 0 1 by root 2. Where I take minus outside, this is similar to the negative value of get psi minus operation. So why do we take only zeros and ones? Zeros and ones are the values which are transmitted across. And therefore, if I have to transmit either 0 or 1, we have these 4 possibilities which we have discussed. Based on this, any one of the Bell state will be transmitted from Alice to the Bob side, that is the receiver end. Now, what happens on the receiver end? First, we'll talk about 5 plus. 5 plus undergoes an C0 operation. Fine. Now, if the second bit is 1, you modify flip the first bit. That is what is a control C0 operation, because target is the second bit and the control, target is the second bit and the control operation comes on the first bit. This is control bit and the next one is the target bit. So what happens is, when I say 0 0 is transmitted, it is 5 plus which has to be transmitted, and you make you flip the second part. Because you have 1, it becomes 0 1. Now that is the first operation. We have performed and control not operation. To this control not output, let us apply the Hadamard operation. Hadamard operation is again done on the bit B. Why we take it? This talks that we move from bottom to top on the representation. So the first bit represents the bottommost line and the second bit represents the line before it. And therefore, we perform an Hadamard operation. Hadamard operation on 0 and Hadamard operation on 1. It is similar to the multiplying it with ket plus and multiplying with ket minus on expanding. If I apply Hadamard operation on ket 0, the resultant would be ket 0 plus ket 1 by root 2. If I apply Hadamard operation on ket 1, which is ket minus, it is ket 0 minus ket 1 by root 2. On expanding and solving it, it represents ket 0 0. The classical bits are 0 0. The similar information goes to 5 minus, where you apply a C0 operation, you result in the same thing, and then you perform an Hadamard operation which results in 0 1. For case 3, you perform C minus control not and then Hadamard operation which results in 1 0 and the last one. So in general, if the value is AB from the Alice side, that is from the sender side, your 5 plus the E bit would be converted to any one of the Bell states. And the Bell states will be received on the Bob's side, which is on the receiver side. and they perform and control knot operation and an Hadamard operation, resulting in, along with the classical state measurements, resulting in the values 0001, 1. So this is all about super dense coding. Thank you.